Well, toxic algae blooms are spreading across Florida's lakes, rivers, and ponds, turning the water green, blue, and brown, and posing some serious health risks.
It's nasty stuff. Craig Patrick explains what makes these blooms so dangerous, and more on the race now to stop them in tonight's Breakthroughs in Science.
I have a collection of algae, cyanobacteria, that from around the country, actually.
Dr. Barry Rosen collects some of the most dangerous natural poisons on Earth.
This is a very thick culture of Cylindrospermum in here.
He stores them in his lab at Florida Gulf Coast University to study how they behave and how they harm us.
It says 2021, so I mean it's thriving.
The toxins come in different shapes and colors.
You talked about browns, so this is another sample of cyanobacteria that came from Orlando.
And he finds them in lakes, ponds, and rivers across Florida, where people swim and fish and where farmers grow our food.
I've heard reports of cattle drinking water dying right then as they're drinking the water.
The cyanobacteria are more commonly known as toxic blue-green algae, and they come in many forms.
Well, there's only 10,000 kinds of blue-green algae.
And they emit different types of poisons. We'll highlight just three, starting with the one known to rapidly kill cows by paralyzing their muscles.
Think about this. The biggest muscle you have in your body is your diaphragm that we breathe with. So when you inhibit the transmission of nerves to that muscle, you suffocate.
What's the most common form of toxic algae that one will find in ponds?
Microcystis, by far.
That releases a toxin called microcystin.
Yeah, so you can see it's a completely different kind of beast.
Dr. Mike Parsons is a professor of marine science and serves on Florida's blue-green algae task force.
Microcystin is a known hepatotoxin, which means it can cause liver damage and kidney damage. And so if a person is exposed to a high enough dose, or any animal for that matter, it could actually result in death of the animals.
We've seen dogs die after drinking tainted water, sometimes within a day.
She walked a few feet and she was kind of rocking, and then she just went over.
And see that red blip just north of Stuart, Florida? In 2017, researchers at Ohio State University linked a cluster of toxic algae blooms to a cluster of non-alcohol-related liver disease in people. Meanwhile, a third type of blue-green algae may produce a brain toxin called BMAA.
We know it's a neurotoxin, and we know cyanobacteria produce it. And we know when their cyanobacteria blooms, people are potentially at risk of the exposure and then result in neurological symptoms.
Researchers have correlated long-term exposure to neurodegenerative diseases in a couple of ways. For example, they found BMAA at significant levels in Floridians with ALS and Alzheimer's, and found none in the control group that did not have those diseases.
That paper was one of the seminal papers to detect BMAA in human brain.
And at the University of Miami, Dr. David Davis tested dolphins that died after beaching themselves. And he found nearly all the beach dolphins had high concentrations of BMAA in their brains and neurodegenerative changes consistent with Alzheimer's.
What we found in the dolphin brain are pathological hallmarks of dementia. Having both the presence of BMAA and also neuropathological changes like we see in the dolphins is troubling.
And in Guam, back in the 1950s, researchers associated a spike in ALS-like disease to people who ate fruit bats contaminated with high levels of BMAA.
You have no idea you've been exposed to it, and then 10 or 20 years later, you might come down with a neurodegenerative disease.
Years ago, University of Miami's Dr. Larry Brand tested shellfish in South Florida.
I found some fish and crabs which had concentrations of BMAA twice as high as the fruit bats of Guam.
But there is no consensus on how or whether BMAA contributes to neurological disease. There's not even consensus on how to test for it.
You're not necessarily getting true BMAA. You could be picking up another amino acid.
It's a difficult compound to identify and measure.
So right now, it's an unknown. The medical community is really split on whether it's an issue or not.
And I think we're still kind of stuck in that rut where we don't have a wide consensus on everybody being confident that they're actually measuring BMAA. And as you can imagine, that really is hindering our study of the risk of it.
Which leads to the need for more research, especially when we see this. We first met Dr. Parsons in 2018 in Southwest Florida. He was testing the air near polluted water and found the same toxins blowing through the wind.
When I first saw it, I was thinking, uh-oh.
The Florida Gulf Coast University experiments line canisters with filters that simulate human lungs and then pumped air through them for weeks at a time.
Your tests found both the liver toxin and the brain toxin here all the way down.
All the way down.
And from here, it could get into your bloodstream.
Yes.
The experiments appear to show what happens as toxic water turns to toxic dust.
And they start to dry out, they may create a kind of powder or a dust, and then that becomes airborne, and then you breathe in that dust.
Around the same time, we also met Alex and Misty Adelot in the town of Stewart. Their poodle Finn died from drinking the liver toxin from the St. Lucie River. And Alex joined a nose swab study through Florida Atlantic University.
They did the testing. He came back positive for the cyanobacteria in his nostrils.
Around 70 people exposed to the toxic blooms joined the same study.
Everybody came back positive.
Everyone that was tested was positive.
But again, no one knows what that really means for long-term health.
The scary part is if the levels get elevated to a point where that exposure would overcome our natural defenses.
And what is that level?
We don't know.
Here's what we do know. These toxic blooms feed on man-made pollution, and decades of poor policy made them worse. We'll show you what went wrong, what our government is doing to fix it, and the technologies already offering hope. We'll break it down in our next edition of Breakthroughs in Science.
Craig, thanks. Tomorrow night, he's going to explain how our government fouled up the Everglades and how it relates to the toxic algae crisis all across our state.